I will tell you guys, you high schoolers, that this is the second iteration of this Future of Construction webinar series. The first iteration was with middle schoolers, and they kept us highly entertained through the question and answer panel. So we believe that even though maybe you might think you're a little cooler now that you're in high school, we believe that you also have a lot to contribute to the discussion. We don't want this to be a one-way discussion. We want to include you as well. You might be busy sketching, and that's fine too. In a moment, I'll show you my Tinkercad design again. And I'm going to preview, so my name is Kellyanne Mahoney. I work for Autodesk. I'm a youth program specialist there. And the product that I primarily support for Autodesk is Tinkercad, which is our free web-based 3D modeling program or 3D design program. It's very easy to use. And even if you are more advanced, I know that some high school students might be more advanced in their 3D design and modeling, it is a really great tool for just quick prototyping as well. Anything yet, Corey? You're muted, Corey.
My apologies. So a basketball court, this is from Anonymous. Basketball court would have personal meaning to me because it's motivation for my goal and career in life. Keep me out of the house and gives me determination and reminds me to look up to people who've made it in their careers and wanting me to surpass them. I don't know if basketball court would be within your realm of building edifices, but
well, it's definitely something that was designed, right? It was designed and it was built, and you know, those public spaces too are really important, particularly if you're in an urban area. You know, a lot of like the parks that are in our neighborhoods are landscaped. So, you know, landscaping is also part of the built environment as well. But definitely I can think of growing up in Dorchester, some of the parks and fields, and even just like where they were situated next to, you know, the water, next to the highway even, how that kind of interplay of the environment and then, you know, the natural environment and the built environment was really interesting. For example, when I used to play softball growing up, if we hit a foul behind us, it would sometimes land in the highway. So if you're just joining us, we're going to launch our official program at 1 p.m. Eastern time. So that's in 2 minutes, but we have this warm-up activity for you. I will actually go over my little structure that I designed in Tinkercad to begin again. But if you're just joining us, we're working on a warm-up activity. You could be writing or you could be sketching. You're thinking about which building, structure, or space in your community has personal meaning for you and why is it important. So Corey from Suffolk Construction is also reading your responses in the question and answer panel. So if you want to chime in and kind of be part of that discussion, we encourage you to do so. We've already heard about a basketball court, which is really cool. What are some other spaces in your neighborhood that have meaning to you, particularly things that are built? So you might sketch from your memory, and you also might compare your sketch to an actual photo. Corey, do we have another comment?
Yes. So Boys and Girls Club Yawkey Way of Roxbury, since I made a lot of friends there and it was an important part of my childhood.
Yep, so those community spaces and those community centers. I know when I was growing up, I went to the Daniel Marr, the Colonel Marr Boys Club, and I remember waiting for like field trips or waiting for buses outside, and there used to be this mural that was painted that was like all little people, and I used to always compare myself to see like if I was as tall as the people in the mural, and it was very colorful, and there were, you know, different styles. It was definitely like people were painting their own people. So very cool. So I'm actually going to show you again, for those who are just joining us, welcome to the Future of Construction webinar series. We're working on a warm-up activity. My name is Kellyanne Mahoney, and I am a youth program specialist at Autodesk. Also, you'll be hearing from Corey from Suffolk Construction during the warm-up activity. We're asking you which building, structure, or space in your community has personal meaning for you, and why is it important? So you might use your memory to make a sketch. You might also compare your sketch to an actual photo. I did that as part of my process. why do elements of the built environment hold special significance in our memories? So I'm going to share with you, if you haven't seen it yet, this is a structure that I remember growing up. This is the gas tank in Dorchester. I often say the gas tanks because there used to be two when I was growing up in Dorchester. There's now one, and this is actually the more famous one. It's called Rainbow Swash, and it was actually painted by an artist who is a Roman Catholic nun named, or Roman Catholic sister, I don't know if nun is the correct word, but Sister Carita Kent. So yeah, when I was growing up in Dorchester, I actually lived in Savin Hill, which I felt like was like we owned the gas tank. I'm sure people in Fields Corner and Neponset might say differently. I actually tweeted this yesterday, and one of my friends who went to the Mather School said that she felt personal ownership because even though she's from JP, she felt personal ownership because she could actually see the gas tanks from her window at the Mather, because the Mather is high up on the hill there. So this always had personal significance to me because particularly I hated dry. I always got car sick when my family took me on trips when I was younger. And the gas tanks, you can see where it's situated is right where where my family would get off the highway on 93. So it was symbolic to me that I was home. It made me feel a sense of home. But this is a very interesting structure. When it was first painted, I believe it was 1971. And at the time, it was actually the largest piece of commercial art in the world. I'm not sure if that's still the case, but it's changed ownership from time to time, depending on the natural gas company at the moment. And there actually used to be two. The original Rainbow Swash was torn down in the early 90s, but when they took down the other gas tank, they repainted it with this new version of it. The history of this structure also is pretty interesting. Again, it was painted in 1971, which was, the nation was healing or beginning to heal from the Vietnam War. And some people actually saw in the kind of abstract rainbow swashes, the blue one in particular, some people thought that they could see the profile of Ho Chi Minh, who was the revolutionary leader from the northern Vietnamese side of the Vietnam War. This offended not only Vietnam veterans in my neighborhood growing up, but even some of the Vietnamese immigrants who had come to the neighborhood after the war, because a lot of the immigrants who were in my neighborhood actually fought on the side of the United States during the war, even though they're in Vietnam, or they were fleeing northern Vietnam because they were Catholic, and Catholics were persecuted during the Vietnam War. So some people actually believe that this was true because Sister Carita was a peace activist. So they thought that maybe she was, trying to put a hidden message in the artwork. She said that that's not true. I tend to believe her, one, because she's a Catholic nun, but two, because she also, was Catholic. And, I just believe that she, maybe didn't put it there on purpose because of that history with Catholicism. A funny kind of lighter note was that many people in the neighborhood also thought that the yellow swash, there was, you could see Fred Flintstone's profile in it as well. So Sister Carita was she was a pretty famous artist as well as a Catholic nun, and she was very into commercial art, particularly pop art. A lot of the pop artists were commercial artists, and she was a big fan of Andy Warhol as well, so you can kind of see that in the graphic nature of the work. So this is my Tinkercad design. Again, my name is Kellyanne Mahoney, and I'm a youth program specialist at Autodesk. So Tinkercad is part of the Autodesk family. It's a 3D design tool that I'll talk a little bit about today. We're going to go into a deeper dive into Tinkercad later this week. But as you can see, even if you're a high school student who's maybe more advanced in 3D modeling, Tinkercad is also just a tool that you can use for quick prototyping. It exports in many different file types as well. So, you can get started in Tinkercad and then upload it into more professional design software. So that is my work. You have work to do too, which is to keep us engaged and part of the discussion. So I'm going to ask Corey again if there's anyone who's talked about cool spaces in their neighborhood that have special meaning for them.
Yes. So our first one is the pool at my apartment. It's important because that's where I had a lot of fun last year with my friends. Next one is a bicycle path. It would be good for the environment, for people's health. Um, Last one that we have is concrete houses with black fences. They are a specific style. I don't know what they're called. Are personal to me because I see those type of houses a lot in El Salvador. It gets me feeling very nostalgic. It makes me want to visit. I have a lot of family there.
Awesome. So getting into some of the themes also that we'll be addressing this week. So I'm noticing that um, a lot of us right now, I think, are appreciating the natural environment more. And we're going to be talking about green building and sustainable design as a way of designing things that have a better or less negative impact on the planet. Also, just thinking about architecture as one of the disciplines within the AEC industry that we're going to be talking about this week. We're going to be hearing from the Boston Society for Architecture later on. So thank you for everyone who have joined us. Thank you for participating. We hope that you continue to participate throughout the series. We're going to get started now. So this series is called The Future of Construction. It's a webinar series and design challenge for high school students. I am presenting to you today from Autodesk. Again, my name is Kellyanne Mahoney. I'm a youth program specialist at Autodesk, where I've been for 3 years, actually. Prior to joining Autodesk, I was actually a teacher in the Boston Public Schools. I primarily taught middle school. So I worked in the Boston Public Schools for 13 years in total. And most of that time was in middle school, and I actually taught middle school English. So many people think that I taught technology, which I did not. I think we have some other English teachers here as well joining us. So I just want to take a moment. So our other guest presenter today is Suffolk Construction. So maybe since you've already heard from Corey can introduce himself.
Sure. My name is Corey Allen. I work at Suffolk Construction. I'm from Boston, Massachusetts, and I graduated from Boston Latin Academy, same school as Kelly Mahoney. And yeah, I'm very happy to be with you all today. And thank you very much for joining us. Really appreciate it.
Thank you, Corey. We also have Brooke Woodson from Suffolk Construction. Brooke, would you like to introduce yourself?
I would, Kellyanne. Thank you. Good afternoon, everybody. Again, it's Brooke Woodson with Suffolk, National Director of Trade Partner Diversity. What Corey and I do at Suffolk is we try to make sure we have people of color, women, Boston residents working on our projects, as well as minority and women-owned businesses. So we're always anxious to engage high school students because we want to let you know about what opportunities there are in construction and let you know the different facets of construction. In particular, we're going to talk about green construction today. So looking forward to the presentation.
Awesome. Thank you, Brooke. So happy to have you here. And Claire is also joining us from Suffolk Construction. Claire, did you want to introduce yourself?
Hi, everyone. My name is Claire. I am Construction Solutions Director at Suffolk Construction. And what that means is I help to support innovation and technology implementation for our job sites. So today we'll be talking a little bit about what that means.
Awesome. Thank you, Claire. All right, and so just before we get started, so I just wanted to let everyone know how to participate. So you will see at the bottom of your screen, the bar should look like this. So there is 3 icons. There's a chat icon, there's a raise hand icon, and there's a question and answer icon. We have disabled chat for this particular session, and the reason being is just to protect your privacy throughout the broadcast today. We will talk to you a little bit about other opportunities that you might have to engage more personally with construction industry and AEC professionals. But for this webinar series, we are disabling chat, but we can also chat to you. You just may not use the chat yourself. You can communicate with us through the question and answer. So we will, throughout the broadcast, we will be checking the question and answer. Corey's going to be my right-hand person to help me out with that when I'm presenting. So we do want to make sure that this is a two-way discussion, even despite the privacy parameters that we put in place. So you may use the question and answer. We might also throughout the broadcast today ask you to raise your hand just to check for your understanding, or maybe to poll you. And you can do that by clicking that raise hand button. So this is your first quiz today, high school students. I'm going to ask you to raise your hand if you understand how to participate today. And Corey's going to tell us how we're doing.
We're getting up there. We're up to 60 people 60 out of the 86 that have raised their hand.
Nice. All right, I'm going to trust you digital natives, you high school students, that you will understand how to participate. Maybe some of you too cool to raise your hand. I think it's cool to raise your hand. I raise my hand all the time. But I'm going to trust that you know how to participate, and we really do encourage you to use that question and answer. Even if you want us to pause for a second and explain something, we are so glad to do that. Our goals for today, so we do have goals. Our goals are to provide you with some exposure to career paths involving construction technology. We all who are here today, particularly presenting on this theme of the future of construction, really believe that through the merging or the convergence of construction and technology, that construction is even becoming a more vibrant and exciting career path. It's not only more exciting, it also presents more opportunity for people of different interests to get into construction. So for example, if you love robotics, you might apply that love to working in construction. We also think that this intersection of technology and construction also makes the career path more accessible to more people as well. We also hope that you'll gain knowledge about how the construction industry is leveraging technology to reimagine how we can build more and build better while having less negative impact on the planet. We also hope that you will gain skills in using the design thinking process and computer-aided design to imagine, design, and create a solution for a real-world problem. So one thing that I want to make clear to you is that this week, there will be so this is a 5-day series. So it's not just today, same time, same link, same place every day. So this is a series that will culminate in 2 design challenges. So know that on Friday, we're going to actually dig more deeper into the design thinking process. And I'm also going to provide you with more direct instruction in Tinkercad in case you're interested in using that as your prototyping tool for the design challenge. I also just wanted to make clear to you too that there will be cool down activities in addition to warm up activities every day. And we will also try to provide you with additional resources for digging more deeply into the topic. So for example, this Make Justice design challenge that I'm going to introduce to you in a moment, there is a resource that we'll link to at the end that you can click on, that you can find out more about issues relating to justice and environmental justice or otherwise, with cool videos that show you like 3D printing houses, for example, and different links and places that you can go to learn more about the topic. So this was actually created as part of the Make It Real contest that is a project that I manage every year for Autodesk. This year we had James Devlin from the New England Patriots as our spokesperson. And we chose James Devlin because he actually has a mechanical engineering background. He studied mechanical engineering at Brown, and before he became a New England Patriot, he was very interested in the construction industry. So this just gives you a sense of some of the resources that you have available for you post this experience. So yeah, so the schedule for this week: Future of Construction, presented by Suffolk Construction and Autodesk. Tuesday, so tomorrow, we're going to be learning about the intersection of robotics and construction, and that will be presented by Mass Robotics, and it's going to be very exciting. Wednesday is the Sustainable Community, so Boston Society for Architecture and EcoRise. EcoRise is a group that is based in Austin, Texas, but they actually do a lot of work in supporting the curriculum in the Boston Public Schools around sustainable intelligence. And it also leads to, for high school students, if you're interested in getting LEED certification, which is something we might talk about a little bit today, it helps you prepare for that exam. Thursday, we're going to be presenting on the theme of designing for justice, and that will be co-presented by the Design Museum in Boston and Digital Ready, which is a cool program that you'll be learning about, and I think a lot of their students are online today. They're working in a program in collaboration with the Wentworth Institute of Technology, which is a great school to go to if you're interested in construction technology. Friday, we're going to be presenting design thinking with Tinkercad. I'm also glad to be joined by the president of ACE Mentors on Friday, and also really excited that she extended this invitation to ACE Mentor students throughout the country. So welcome if you're here from ACE Mentors. The culmination of these design challenges will actually, your work will be curated and presented as part of a virtual exhibit by the Design Museum in Boston. So just to give you a sense of the design challenges that we're going to be completing today, or not today, but this week, they're on the theme of social justice. In presenting this experience, we don't want to forget about the context of why we're presenting this. And a lot of this has to do with the health crisis. So a lot of you are at home working on this when we'd like to all be together physically and working together in real hands-on projects. So we don't want to forget about the sadness, the stress that we've gone through distance learning, or, even some of the people that we've lost, or if you've, been personally affected by COVID. But we also see this as an opportunity. I see this health crisis as an opportunity to pause and rethink the way that we're doing things. And that's kind of the vibe and kind of the mood of this whole series, is that there are many things that are going on in our society that could stand to be changed. And now is the time that we can change them. So one of the things we can change is, the environment. So thinking about how the environment is an issue that, is kind of in the background, but is becoming sort of a forefront, even in the early stages of this crisis, when we're noticing, oh, wow, I can hear birds chirping because there's no cars on the road, in a simple way. We might also even think about structures that are in place right now, currently in our society, that are putting an environmental justice burden on some people and not others. Why, in some communities are there lots of trees? And if we overlay a heat map on a community, that, some people are suffering more than others. And then how, if we overlay that with, economic data in a particular neighborhood, what can we extrapolate from that? So we want to think about issues of environmental justice in our neighborhoods or community that we can solve through our creativity and our imagination and what we're learning about the designing for the built environment. Another issue of social justice that you can address through this series is to create a model that showcases how you would address an issue of social justice through architecture. So that's the particular design challenge the students in Digital Ready are working on through their experience this summer at Wentworth Institute. But we also want to invite others to think about ways that, as we're rethinking things, what are some places in our neighborhood, or who are some heroes in our neighborhood that we could, rise up to the level of others that, maybe we shouldn't be honoring. So those are just some examples of how, and even just in thinking about the work of an architect, you're not just designing objects, you're thinking about the landscape in which they will exist. So are they culturally responsive to the places that we are designing for? So again, my name is Kelly Mahoney, Youth Program Specialist at Autodesk, talking about the future of making, particularly around the architecture, engineering, and construction industries. So in thinking about AEC, which is an acronym that we use in this industry, where that's an acronym for architecture, engineering, and construction. So we ask a lot of professionals from these industries. Architects, we ask them to design beautiful spaces that are, responsive to human needs. We ask engineers to make sure that those spaces, fit in the environment in which we're designing them for, that they're structurally sound and that they're safe. We ask the construction industry professionals to take those designs and honor them by building them with materials that are reflective of the integrity of the design, and also that represent the craftsmanship of those who are working in the industry. So we ask a lot of them, and we also increasingly have been asking these industry professionals to collaborate more together, and then on top of that, create designs that would have a better impact on the planet. So what will the future of construction look like? I actually thought about this quite a bit in the last iteration of our series with middle school students. High school students, similarly, thinking about the future of construction. A lot of people in the construction community think that construction is going to start to look more like a factory, or look more like the manufacturing industry, and also that we can learn more from the manufacturing industry in order to be more productive in the construction industry. So when we think about that, so obviously the industrialized construction is working in a way that is a more controlled environment, but it's also more organized, more efficient environment by organizing our work in assembly lines, for example, and prefabricating things inside a factory, for example, before we bring it to the construction site versus building it at the construction site. Allows for more middle class jobs that are safer. So that's one of the benefits of industrialized construction. Another benefit is if we think back to, when the automobile was first invented, initially it was a product that only people who were rich or upper class could actually afford. But by organizing the work of making automobiles in a more manufacturing context and make it more organized, more efficient, use of assembly lines, we've actually were able to drive down the cost of automobiles so that most people, today can actually afford an automobile. If it's used, that's fine too, but it's made the cost actually drive down as well to make automobiles more accessible. Similarly, today we face a housing crisis. Even people that are middle class and upper class, particularly in cities in Boston, cities like Boston cannot afford to achieve that American dream of owning a home. So we think that by learning from the manufacturing industry, not only could we build things that are better for the planet, but also better for society in order to make housing more affordable. This is an example actually from a company called Factory OS, which is in California, and they are working to kind of put that theory into practice through modular, creating more modular housing and organizing workers in that way. So who is Autodesk? So we make software for people who like to make things, people who like to innovate in the built environment. We also make products for those software for people who design things not in the built environment, like cars. So the Tesla was designed using our software. Skyscrapers, bridges, even some of the cool animation that you see in like video game graphics or the CGI in blockbuster films is designed using our software. A lot of when we think about the future of construction, a lot of what we're doing in terms of changing our practices in the future of construction is driven by global trends, big global trends. So for example, one global trend is the increase of the global population. Currently right now, this number is from 2019, but it's pretty similar to now. We have 7.5 billion people on the planet. By 2050, we predict that there will be 10 billion people on the planet. So that's one trend, that the population is growing. Another trend is that the population is becoming more centered around cities. So currently right now, 3.5 billion people live in cities. By 2050, we estimate that 7 billion people will live in cities. So that's another big global trend, is kind of the urbanization of the population. So all of that demand, all of that, the more people, is driving needs in our industry. So for example, by 2050, in order to meet the demand of housing, we'll need to build 13,000 buildings a day. We won't just need housing, we'll also need infrastructure to support people moving to the cities, for example. So we'll need more highways, we'll need more railways, we'll need more public transportation as well. In order to fulfill the demands of the population by 2050, we're going to actually need to create 30 times the amount of roads and rail that we currently have per year. So currently right now, so this is in the status quo right now, just due to climate change, there are $4 trillion worth of assets that we have, so bridges, roads, buildings that are at risk due to climate change. By 2050, 5 billion people are predicted to suffer from not having access to clean water. So that's like half the population. In addition, currently right now in the status quo, 90% of those at-risk assets that we're talking about are actually along the coast. So they're already being impacted by some of the phenomena that are associated with climate change, like storms and earthquakes and everything else. So more is inevitable. So, you know, we need more buildings. People are moving to cities. I don't want to make you think that that's necessarily a bad thing. You know, there are other global trends about more that are good. For example, every day, more people are actually joining the global middle class, which is wonderful because they will have access to the same, you know, equitable access to food and to transportation and to technologies like iPhones and things that, you know, that people would like to have. But again, at the same time, less is a reality. Natural resources are not infinite. You may have learned that in your earth sciences class. So we need to think about how we can do more with less. Another less that we have is a less, we are suffering as an industry from having less talent. So there's less people who are actually going into the construction industry. 20% of the construction industry right now is retiring. So we're very worried about that as an industry. In addition, architects, I think over 30% of architects are over the age of 55. So for us, that's a little bit worrisome, but for you as a student, it's an opportunity because these are great jobs that you can get into, great middle class jobs, great upper class jobs that will allow you to be able to support your families and build your communities. Just some more statistics. So the built environment, when we're talking about it, again, we're talking about buildings, bridges, hospitals, schools, you know, transportation stations, airports. 25% of the world's water right now is consumed by the built environment. In addition, the construction industry is responsible for 30% of global waste. And finally, the built environment is also responsible for the use of 40% of global energy as well. So as an industry, we have a lot of problems, and we're reaching out to you, young people, so you high school students who we also see as, when we talk about the future of construction, we're not just talking about this big idea, we're also talking about you. We believe in you, that collaborating with us, that we have an opportunity for better. So I'll talk a little bit also about how the industry might leverage some technologies in order to make the world better. So the way that the construction industry or the future of construction is changing, and even just the future of making things in general, things are changing, the way that we make things are changing, and the nature of work is changing. And a lot of this is actually being driven by some what we call mega trends in the industry. And these mega trends are driven by trends in technology. So for example, big data, artificial intelligence, and predictive analytics are driving change in the industry, and this is positive change in the industry. A lot of times when we hear about automation or robotics, we worry about, you know, the first thing that might come to mind is, oh, robots are going to be taking our jobs, but that's not the case. And I'll talk about that in the next slide, about how robotics are actually, and automation is actually providing better jobs for people. Prefabrication and offsite construction, so that concept of industrialized construction that I talked about before, the Internet of Things, so how we can use things like beacons or sensors in order to collect data and make buildings perform better, is impacting the future of construction. And also additive manufacturing. So if you've ever heard of or seen 3D printing before, that's one example of additive manufacturing. When we think about the future of work in construction, here's just a snapshot of how we think the future of work is changing. So there will be new teams, new roles, and new skills for existing roles. So again, if you're interested in robotics, construction could be a great career path for you. If you care about human rights, for example, supply chain might be something that you might be interested in because of the way that industrialized construction is making the whole process of construction more connected and more controlled and more efficient, you know, through even also using machine learning, we can actually more ethically source the materials that we're using. So making sure that in the supply chain that people are not being exploited in the process of building. So there's all types of really cool, you know, modeling and simulation we'll talk about as well. So there's all different new pathways into construction that we're very excited about. Let's pause for a second. So going back, so I was talking positively and optimistically. When we think about the future and cities of the future, sometimes we pessimistically think of images like this. Raise your hand if you've actually, this is from a film. Raise your hand if you've seen this film before, you have a sense of what film this is. Corey, how are we doing?
We are at 25 hands raised.
25 hands. Does anybody want to gander a guess at what film this is?
Feel free to type it into the question and answer section. All right. We have Ready Player One.
Yes. Ding, ding. What is it? Winner, winner, chicken dinner. We have no chicken dinners to give, though. So this is more of a dystopian. And again, I can't escape my role as an English teacher, a former English teacher. So this is a more dystopian view of what a city might look like in the future. The Ready Player One, if you haven't seen it before, it's actually a good film to watch, I feel like, during the summer with your family. It's a vision of what society might be like in the year 2045, and it's a very dystopian sort of view. There are some cool aspects about it, like how people can work together from different places in virtual reality in order to solve problems, which is cool, but the reality is not so cool. So I offer you a different vision of what the future could look like. So this is the concept of what a building might look like in the future that was conceptualized by a group called Arup, which is a group that is actually based out of Boston. So they came up with this concept. This building doesn't exist yet, but it's an idea of idealized utopia, what a building in an urban environment might look like in the future. So it also illustrates some of the things that we've been talking about in terms of the future construction. So the building might be arranged in modular components. So thinking about like a building almost like kind of like IKEA, like the kit of parts that you get to put together furniture. If you make a building in a more modular or more configurable way, maybe you're trying out something new and that fails. Well, rather than having to knock down the whole building because one of the components doesn't work, you can switch it out for a different component. Even the materials that are being used, so it might have an algae facade that produces biofuel. It might have solar paint on the outside in order to increase solar gain so that solar power can fuel the building. Building systems could be fully integrated with the smart grid and urban resource stream. So we'll talk about that a little bit in the film that I'm going to show. Robotic assembly, so thinking about how robots can continue to maintain the building. So when you're thinking about the future of construction, you're not just, you're not just making the building and then walking away. Because of the way that you're making the building and designing it in CAD and putting that into a building information model, and then maybe connecting it with sensors or other types of IoT devices, we can continue to capture data about the building in order to make the building continue to perform well and also to learn from the building too. Urban food production might be a component to the building. So on Wednesday, we're going to be hearing about the concept of vertical gardening from EcoRise, and they're specifically going to be talking about urban gardening as well. Building membrane converts carbon dioxide into oxygen. So thinking about buildings that don't only not have a negative impact on the environment, but actually might make the environment better. So this is a cool video that I like to show because it just kind of is a quick snapshot of all the things we were just talking about. So this is the story of a 3D printed steel bridge. It's a pedestrian bridge. It was constructed in Europe. And it was 3D printed in steel using robots. So that's one of the things. It took 4 robots to build, 6 months of printing, and also quite a bit of stainless steel. However, since it was 3D printed, it would use fewer materials because it used an additive manufacturing process. As you can see here, so this is this is not the actual view of the bridge, this is a rendering. So again, if you're designing things in the built environment digitally, you can do things like create photorealistic renderings and kind of like cool walkthrough sort of marketing videos of what you're designing in order to communicate your designs in a more immersive way. Another cool element of this building, so again, when you're creating this sort of digital twin of a structure, it allows for you to not only create these really cool immersive renderings, you could also even take that digital twin before it's even built, upload it into like a VR environment, and then even simulate how the bridge might perform even before it's built. Another cool element of this bridge is because it was designed in a building information model, they were able to insert sensors in the bridge that after the bridge was built, that the bridge can still keep telling the city planners information about how the bridge is performing. This is just a pedestrian bridge. However, the city planners can then extrapolate data from that information and learn about, how they could apply it to other parts of the city as well. So just really quickly, just wanted to give you a preview of Tinkercad. You don't need to get onto Tinkercad now. We're going to go more in depth in it on Friday. But I just also wanted to prove to you that you can start to design cool things in Tinkercad, even though some people think that it's just for kids. So this is a cool design that was based on the abalone house, which is an example of biomimicry. We're going to talk about that on Friday. But this is how I might design it in Tinkercad. So I'm using the scribble tool that allows you to make quick sketches in 2D. So you can rotate your designs. You can also use this, I'm demonstrating here Smart Duplicate, which I think is one of the coolest things about Tinkercad, is once you duplicate something, so you're using that Command D key, once you duplicate it, it doesn't just remember the shape. If you make a slight adjustment to the shape, like make it slightly smaller and rotate it an increment, you can keep hitting that Command D and make really cool, like architectural, conceptual drawings as well. So that's just a sneak peek of something that you might learn on Friday if you stick with us. This is actually what it looks like when I fully finish designing it. I didn't design that. That's the architectural rendering. So that's just a sneak peek for Friday. Also just wanted to, if you already are Tinkercad Pro and want to move on to a more professional tool, this is another tool that you might use, is Form It, which is part of the Autodesk family. It's a conceptual architectural tool. It's free for students and educators. It also has a web-based version for some of you that might be working at home from Chromebooks. And you can see, using Form It, you can actually integrate geographical information that's publicly accessible into your model. You can practice visual programming and kind of thinking about how you can collaborate with automation in order to create computational designs. And then ultimately, you can also integrate your model into Revit and have all that building informational modeling information in one place. I'm also going to provide you a link at the end of this episode to a tutorial in Form It. So this is how you could build the Farnsworth house in Form It, which is a classical example of architecture that's very well known. So it's how you can recreate it and do the cool things with integrating maps and situating it in an environment. So again, so just to summarize, we're asking a lot of you high school students, but we believe in you and we want to work together with you in order to build more, to build better, and to have less negative impact on the planet. And also just by designing things digitally, thinking about how we can design things that we would have never imagined before. So for example, this is the Museum of the Future in Dubai that was computationally designed. And through the power of using professional tools and innovative processes, it exists. So that's my part of the presentation. I'm going to save questions to the end so that we can move on to Suffolk's presentation. So I'm going to stop sharing here.
All right, great. So I'm going to go ahead and share my screen. Just let me know when you can see it.
You can see it there.
Okay, great. So today we're going to talk about what Suffolk is doing to advance the construction industry through technology. And before we kick it off, we're going to start with a brief video on Suffolk's approach to construction.
At Suffolk, we've always sought the most inspiring solution for our clients' challenges. To lean on our ambition, to innovate. And so as a new era dawns, we continue our pursuit of better. Continue to drive real change and innovation in an industry ruled by the status quo. Because we've never seen impossible as an obstacle, but as an invitation. Not as a deterrent, but a dare. To take your vision and find new ways to make it a reality. New ways to push boundaries. New ways to look impossible in the eye and prove it wrong.
Okay, so a few things we're going to go over today. First, we'll talk a little bit about the background of Suffolk Construction and what it means to be a general contractor. And then I'll give a brief tour, virtual tour of our CoLab, which is our innovation space. We'll also talk about some of the technology and innovation we're using, and then we'll also finish up with some of the forward-thinking projects we're doing in Boston. So to kick it off, Suffolk Construction is one of the nation's leading general contractors. So if you could, raise your hand if you know what a general contractor is. And Corey, if you could help me out. Oh, I actually can see it on the side. Okay, great. We're getting a few. We've got 24 participants at this point, which is really impressive. Not a lot of people know what a general contractor is unless you're in the industry. So when you think about construction, you think about hard hats, you think about jackhammers, you think about the guys, boots on the grounds, the guys actually doing the work. We're not those guys. As the general contractors, we're behind the scenes managing those guys. So the way I like to think about it is we're the glue in what it takes to build a building. We work with all the stakeholders involved in construction. That includes the client and developer. So that's the person who finances the job and has the vision for the project. We work with the design teams, architects and engineers, and we work with the trade partners. Those are the people actually doing the work. And on any given project, you're gonna have dozens and dozens of companies on a job. So that's a lot to manage. Suffolk was founded in 1980s, and at this point, we're a $4 billion privately held company. So being privately owned means that we have one person managing the company and the vision of the company, which is great because that makes us a very nimble general contractor. We work across many sectors, and just to add some context to what these sectors mean, I have a few projects that are in Boston. So for commercial, we've worked on the Millennium Tower in 1 Dalton. Healthcare, we've worked on Boston Children's Hospital. Education, we work on a lot of high schools, Saugus Middle School and High School, Somerville High School. We've worked on the Logan Airport terminals, and we've also worked on many casinos, including the Encore Casino. We also work across several locations. We have 10 offices and about 160 active projects. So one of the key differentiators of Suffolk is that we have a really robust innovation infrastructure, and we've put a lot of investment into this innovation infrastructure. What you see on the screen is what's called the CoLab, and that's part of it. So this CoLab is a physical space in our main offices, and it serves a few purposes. One, it's a really tech-enhanced space to support collaboration for our job sites. Two, it helps us broadcast project data, and Kellyanne touched on the kind of data we're collecting, including BIM information modeling, so those 3D models of your job site. And we also use this space to communicate out emerging technologies, and Kellyanne also touched on that. Think sensors, think visual aids, think improved materials. This is the space where we come to connect with our project teams and talk about successful applications or successful technologies used on job sites. So let's break down this space real quick. I'm gonna go clockwise, starting with these live feeds. So these 4 screens are broadcasts of our job sites. And what I mean by live feeds is that we have a camera that's picking up real-time live feed of our job sites. And it's really beneficial for a number of reasons. It gives you that eagle eye perspective of your job, which is so beneficial from a logistics perspective. Moving on to what's called the huddle wall. It's a 13-foot long screen. So imagine this long digital touch-enabled screen. We use it primarily for planning and scheduling. And the reason we have this long screen is because, like I mentioned before, we work with multiple stakeholders and we have to collaborate between all of those groups. So it's nice to have a space where we can all be at that board planning together. In the back, we have a space called the Cave, and this room is fully devoted to virtual reality, and we'll touch on that a little bit more here in a minute. The data wall is is 9 screens, and it's set up to be one full screen, and we can manipulate those screens to be as many different screens as we want and have as many visuals as we want. It's also touch enabled, and we call it a data wall because this is where we broadcast project team data, and we have an entire data team dedicated to collecting and cleaning the data that's coming in from our job sites. And then lastly, we have what's called the hub, and we actually have 2 hubs in this space. And we also use the hub on job sites. So the hub allows us to have video conference enabled video chats, and we can also use it as a digital planning board. So traditionally in construction, we'd have hundreds, thousands of sheets of paper for a given project. That's the design of the project in 2D. And as we move into a more digital space, we have those 2D documents because that's what's traditionally used in AEC, so by architectural and engineering firms. But we can have it in a digital form on the Surface Hub, and we can also have it in a 3D form using something like Revit from Autodesk. Now, what I want to call out here is you might be thinking, well, whatever, like technology, that's not that impressive. The thing about construction is that 5-10 years ago, we were all using just a notepad and a pencil. Everybody was storing information on their own C drive, on their own computer, or just on a notepad where it never really circulated well to all the stakeholders or their project team. And this space is meant to socialize technology so our teams can leverage the cutting edge tools that are available to them. So each of these labs exists in 7 of our main offices. So we have one in Boston, New York City, which is where I manage the lab, Miami, Tampa, Dallas, Los Angeles, and San Francisco. And the reason we have these labs across the nation is so that when we do surface a new technology or a team comes up with a good process workaround, maybe they come up with their own app. We encourage all sorts of innovation on job sites. And when this does surface, we want to make sure that we can scale it to our other regions and make it a national solution as quickly as possible. So let's talk about some of the standard technology that we use on our job sites. I mentioned before that in the lab, we have this space called the Cave, dedicated to virtual reality. This space is really good for our clients and design teams. And that's because in the past, if a client wanted to visualize his or her space, we would make a physical mock-up using, offsite in a trailer or in some other space, maybe even on the job site in real time. We would ask them to make decisions on their design based on this physical space. That would take a lot of time, take a lot of money. It caused confusion with clients who were going between 2 design ideas. So what VR allows us to do, what virtual reality allows us to do, is make mock-up units a lot more efficient and make it a lot cheaper because we can make changes in that virtual reality space so much easier than we would in a physical space. 4D scheduling is another tool that we use, and we use it to link our 3D model so that that digital design of the model, and we'll see what that looks like here in a minute. We link that 3D model to a schedule so we can understand as our schedule progresses where we are in construction and what the design and what the project is looking like at any given point in time. So let's first look at what VR looks like. So this video is one of my team members walking through the Encore casino. And so what it looks like is she's in the cave, and this projection is up on a wall, but she is fully immersed in this Encore this is a hotel room. So she's fully immersed in this hotel room, and this is all she sees. And as I mentioned, she's on the fly, able to make some design decisions by flipping through a few interior design options. So yes, so she's changing photos, she's able to change the floor and the wallpaper. And I'll let her navigate into the bathroom. And as it turns out, we made this mock-up virtual reality unit for the owner, and it ended up, I haven't walked the Encore myself, but it ended up apparently looking exactly like what we constructed. So we were able to make all of our design decisions for our hotel rooms through virtual reality. So for 40 schedule, you're gonna watch as one of our iconic buildings in Hollywood, Florida is built. Based on this timeline, based on this schedule in the upper right, you'll notice that the red dashed line progresses over time. You'll see that more and more is constructed. This is considered a mega project. So what that means is we have multiple projects going on at once. So as the schedule progresses, you can see the projects being constructed concurrently. And if you can't tell by now, this is a hotel tower, a guitar hotel, which is very, very cool. It's a project that I was actually on before moving to New York. And if you want to look it up, it's Hollywood Hard Rock Hotel and Casino. So in terms of efficiency and logistics, we're able to evaluate where we might put the crane, how we want to work concurrently between these projects, where we are at any given time. So this is a really, really valuable technology tool. All right, with that, I will go ahead and turn it over to my colleagues.
Thank you, Claire. Again, this is Brooke Woodson with Suffolk. Me and my colleague Corey Allen are going to talk about some of Suffolk's green-related projects that we have that are currently under construction. So the first one that I'm going to talk about is Boston University Center for Computing and Data Sciences. I happen to be a graduate of Boston University where I got my master's degree, so this project is of great interest to me. The first thing you'll notice is the striking design of it, and it's designed to look like a stack of books, which is really innovative and different. It's caught people's attention. But this is also, again, a green building project. So it's been designed to be carbon neutral and fossil free. How do we achieve that? One of the things that we'll be doing, instead of using typical gas or other sources of energy, we'll be using geothermal wells, which will be pulling heat out of the Earth's center. If you go down about 10 to 20 feet under the Earth, there's a heat source there, and then you use pumps to bring that heat into the building and heat it that way instead of using fossil fuels. And in the summertime, you just do the reverse. You pump the hot air out of the building and put in cool air from the Earth. So it's a really innovative way to do it. Other green factors with the building, there'll be 3 layers of glass to retain heat. I grew up in an old house in Roxbury, and on windy winter days, it felt like the wind was coming and blowing directly on you. So you can imagine how much having 3 layers of glass will do to preserve heat and also cool in the summertime. The electricity is going to be generated from a wind farm in South Dakota. So again, not using fossil fuels for electricity. Again, you reduce the carbon footprint down to 0. And then not only does the stack of books have, again, a visual appeal to them, but they also create a series of green terraces that can be used. So usually when you have a green building, it'll just be on the rooftop where you have a green terrace or green garden up there. But this, because of all these cutouts you see in the design, you can have green terraces right along those, right all the way up through the building. So it's a 19-story building. Construction started in the spring. It was interrupted obviously with COVID and the construction shutdown we had in Boston, but it's gradually has begun to ramp back up, and we're really looking forward to it. And it's right in the Kenmore Fenway area of Boston. So with that, I will turn it over to my colleague Corey Allen.
Awesome. Thank you, Brooke. Good afternoon, everyone. Once again, my name is Corey Allen. I'm going to be talking about one of our projects, which is currently in redesign, Winthrop Center. Claire, can you go to the next slide, please? Sure. So overall, going to be talking about Winthrop Center. I'm sorry, can you go back one, Claire? Thank you. So overall, going to be talking about Winthrop Center, but this building is set to be the largest passive house building in the world. Passive house is a technology and way of reducing building impact on the environment that started over in Germany, but has made its way over here. A couple of criteria for passive house certification are clean air exchanges, insulation in the wall, blower door tests, where essentially they close off all of the windows and all of the doors of the building, and they do a test where they blow wind into the building, and they have monitors on all of those doors and exits to make sure that the building is sealed tight. Also making sure that we're retaining the heat, and then using solar and biomass energy. Next slide, please. So this is just to give you some idea of where the project is. So the yellow square or the yellow T that you see is where the building is going to be. On the right-hand side, that's Federal Street. So if you are familiar with the Boston College Club, it's over there on Devonshire Street, where the former statue used to be that they just moved to Fenway, is over there. I think that the Cafe de Boston is also over there. Again, it's the financial district. So when you all are graduated in your architects and engineers and financial analysts, you all will be down in the financial district more often. Next slide, please. So typical office plan, basically they try to fit as many people as they can into the office floor space. So right here, you see you have offices on the interior of the floor plan, which may not necessarily make best use of natural sunlight, and also being able to have meeting spaces. If you can go to the next slide, please, Claire. This is what we're looking at in the future. So again, previously you would have offices more on the interior. With this, you have open spaces all along the exterior of the building, which make use of the natural sunlight coming in and are able to allow people to have better views. There have been studies that individuals that see nature and light during the day actually feel better. So that's one of the well principles that Millennium Partners has used in the design of the Winthrop Center Tower. Next slide, please. So this particular slide shows one of the ways that the company is trying to make the office floors more agile or able to be changed easily. So previously, where you would have wires potentially going where people's desks are, they've built this, I think it's 2 to 3 inches panels inside of the floor, and those can be popped up. And so those blue wires are the Ethernet cables. So essentially, if a company wants to change while they're in the space, their office configuration, you don't have to take all of the pieces up. If you just want to reconfigure a couple of spaces, you can actually do that. And if there is a new company that is coming in, they can keep the existing spaces, or again, if they want to change just a few pieces, only a few of those panels have to come up. You reroute the wires, and makes it relatively cost efficient for the owner, as well as keeping the companies that are moving into the office spaces able to design it in the way that makes them and their employees feel most comfortable. Next slide, please. And so again, as we talked about, having open space, having plant life in the office space, and as well as having lots of sunlight being able to come in, which also helps people through being able to see light, and then the plants do photosynthesis. And again, please, if you have any questions about anything that I'm talking about, please type it in to the question and answer, or if you've had any questions about what Claire, Kellyanne, or Brooke talked about, please type it into the Q&A, and I'll be wrapping up shortly, and then we'll get back to your questions. Thank you. Claire, next slide, please. So this is a rendition of the building. Again, right now, the project is on hold for a redesign due to COVID, but this is the entrance looking from Federal Street. So again, if you're leaving South Station, where the main train terminal is, on the right-hand side, you would see the Federal building, and straight ahead, you would see the Bank of America building. If you continue on Federal Street there, this is the view of the project that you can see. Again, the owner of this project is Millennium Partners, and Suffolk, we are the general contractor for this project. Next slide, please. And yeah, that's it for my presentation. Again, I know we didn't have a ton of time for questions last time. I tried to do a truncated version of the presentation so that we could have more than enough time for question and answers. And we did have a couple from early on, and then again, we'll get to them in the order that they were received. So we had one from earlier. Throughout the summer break, I've actually been watching the construction of a house from start to finish right outside of my window, which I think is pretty cool, right? You know, in this time, and as we're looking at construction, that you're able to actually see a building being constructed out of your window. That's very cool. If you want to give us some description of that, we can most certainly look into that and make that a part of the discussion. Kellyanne, question for you on Tinkercad. How do you make the top colorful part? I think this student is referring to the gas tank. It looks really detailed and complex. I think that's a compliment for you. And usually there are only basic shapes that you can make with AutoCAD tool.
So that was not as pretty of a process as making the bridge and the landscape. One thing that I would say in terms of encouraging people to design in Tinkercad, even if you are used to using more advanced software, is I think that constraints. So there are some constraints within Tinkercad in terms of making more organic shapes and fitting shapes, and you can't really do decals like you can, if you're using like a Fusion 360 or a Revit. But yeah, it was a process. It was a long process, but I used that scribble tool to make the little squiggles at the bottom, and then had to fit the stripes at the top. So it was a long process, but I think that some of the constraints within Tinkercad make you more creative.
Awesome. Give me 1 second. Just trying to respond to the questions that I can just via type. How is COVID-19 affecting the current design of the office building? So right now, we are looking at lowering the height of one of the towers of the building. One of the issues with COVID is, I'm not sure if you all are paying attention to the financial markets, but there are some disruptions in the way that banks are lending, and also the way that people are spending. I know for me personally, I have tightened my purse strings since COVID started, and so with that being said, the office is being redesigned for what the building occupants may be looking for in another 3 years. So the projected end date for this project is March of 2023. And again, the interesting thing about what we're doing in construction is, although the building started going up, I think about 1.5 years ago, we really had to look 4 or 5 years in advance to what is going to be happening at that time and base design and actual construction on that. And in this instance, with COVID, which is hopefully a once in 100 year happenstance where we have a worldwide pandemic, there are a lot of things to consider. For instance, elevators. You can only have 2 people right now in the regular size elevators. So as you're looking at tenants, whether it be office tenants or residences, you have to think about placement and amount of people that are going to be coming through the building. So that's how that changed. Our next question was kind of going back again, Kellyanne, to the beginning. Wanted to learn a little bit more about the 30% waste in our environment due to construction.
So what was in the question was?
So the question was to return, and can you expound on that, where that waste is coming from in the construction industry?
If I can answer that, I just know that it's 30%. I mean, I know, for example, in the manufacturing industry, a lot of waste comes from spare parts that are unused. I'm sure, I feel like Brooke, like Suffolk might actually know a little bit more about the waste in the construction industry.
Yep, you're exactly right. It's a lot of materials that don't get used. They get purchased during the construction of the project. And then our teams tend to be very efficient. And then you're sort of left with all these materials that don't get used. And the question becomes, of, what do you do with that? But again, with all the modeling that you talked about earlier, we can be more efficient with that process and just order basically what we need, right? It's never going to be 100% correct, but that's sort of where most of the waste does come from.
Mm-hmm. And also just using new processes, so like more additive manufacturing of components and a kind of a more of a like micro factory model eliminates waste as well, because the only material that you're actually using is the part that's in your digital design. So, there are whole buildings that have been 3D printed. However, when we think about prefabricating components, it maybe isn't the whole building, but it's different parts of the building that could be, 3D printed or made in a more manufacturing sort of process.
Next question we have, when we use Tinkercad on Friday, will we go over the basics?
Yes, so on Friday is meant to be the basics of Tinkercad. We're also going to be joined by Deanna, who is the head of education for the design museum. So she's going to be talking about the design thinking process. So giving you a process for creating, and then I'm going to get into the more kind of technical, how to make something in Tinkercad. And I'm actually going to be demoing how I did that whole abalone house model.
Awesome. We have another question. If we want to go into this field, what sort of skills are good to start learning as a high schooler? I have some thoughts. Would anyone else like to take a crack at it before I do?
You can take it, Corey.
Sure. So again, this industry is wide swathing. We'll just start with the individuals, the men and women that are building the buildings, making sure that you understand geometry, right? Those shapes and angles and sine, cosine, and tangent are all very, very, very important. So if you're sitting in geometry class and you want to be a builder and you don't think that SOHCAHTOA, I don't know if you all remember that, sine equals opposite over hypotenuse. Yes, the individuals that are building the buildings use it on top of the people that are designing the buildings.
Go Dragons.
Yeah, go Dragons, right? Yeah, it's been 20 years and I still remember that. If you want to be on the developer side, again, I think one of the big pieces that is transferable to any career is really having relationships and being able to deal with people from different backgrounds, people with different skill sets, people with different personality types. So I think that's really important. If you're looking at architecture, again, I think math is, again, very crucial. Making sure that you understand science. Again, there are things like wind tunnel tests that you're going to have to do, particularly in downtown Boston. One of the concerns is as the building goes up. So I think at this point, the height of the building, or prior to the redesign, was 691 feet. You have to think, if you're building a structure that's going to go up 691 feet, the wind that we're feeling, most of us are between 5 and 6 feet that we're feeling, and sometimes we get blown over. Imagine a building that is 100 times taller or more than we are. So you have to be thinking about that. You have to think about wildlife. So where we have some buildings that are made out of glass, how do you try to keep birds and other wildlife safe from flying into the building or trying to nest and potentially hurting themselves on the buildings? Yeah, so again, I think that paying attention to your subjects, and again, I used to be an English teacher, And as a part of this, you're going to have to read. You're going to have to understand things. So making sure that your grasp of the language that you're working in. So I know someone mentioned El Salvador earlier. So whether you're in El Salvador, whether you're in Vietnam, whether you're in America, understanding the primary language and being mindful that you're going to be working with people that speak different languages. People have different accents. So just really being open to working with different kind of folks and trying to have command of the language of where you're at, but then also being mindful that you may have to learn a little bit more. I know one of the things that's helped me being on the construction site is understanding Cape Verdean Creole and Spanish, because we do have a lot of workers that speak Cape Verdean Creole and Spanish, as well as Haitian Creole. So yeah, if you have any more particular questions about that, we can dive into it, but that is it at a short.
I could just add in, I think soft skills are really important too, Corey. Construction is an industry where if you're not there early, you're late. The jobs start very early in the morning, so you have to be on site and prepared, ready to go when the job starts at 6 or 7 in the morning. Your ability to listen and work with others is critical, because safety is a major concern on construction projects. And if you are not paying attention, if you're not following instructions, if you're not following safety protocols, you put yourself and others at danger. You're working with equipment that is extremely heavy, and you're working oftentimes at a very high level, where slips and falls and all kinds of things can happen to you. So you have to be disciplined enough to follow those kind of protocols that are laid out. I think Suffolk has a great safety program and a great record at this point, but that's because we hire people who are going to pay attention to the rules, who are going to make safety a first priority. The most important thing we say at the end of the day is that you go home safely to your family. You go home as good or better than when you started the day. So that's sort of our attitude about that. But so those so-called soft skills are really critical to being successful in construction.
Awesome. And Kellyanne, right now we have 2 more questions. Do we have time to get to those?
Yes, so for those of you who are still hanging around, which is wonderful, it's almost all of you, so we appreciate your patience and flexibility. But I do have just some resources that I can share with you. We had a cool down activity, but let's wrap up the questions, and then I will share my screen and extend some resources out to you that will help you as you continue to think and innovate.
Super. So one of the questions is, can construction waste not be recycled? It absolutely can. I don't know if any of you have been to the project that is in Somerville. They call it Assembly Row. One of the things that I think that probably the coolest thing that I've seen, and they actually did it also on the Rose Kennedy Greenway, is they use the old steel beams from the highway actually as pieces of art. And it's also, I think, kind of like Kellyanne was saying, a reminder for when it used to be. So one of my favorite things when I was young was to go on that bridge overlooking the water. But now it's not there, right? And right now there's a greenway in one space, and then there's basically a small city in another space. But seeing those steel beams remind me, yes, I remember when I was young, riding up to New Hampshire and riding over that bridge is my favorite piece. And now I'm still able to see those steel beams. So I think it's a reminder for people that may not have seen 93 going above downtown, what it used to be like. And then for the individuals like me who were there saying, yes, I remember what that was. We had another question. For a person majoring in mathematics and want to pursue math and problem solving as a career, could this field be helpful in the future? I think so, but Kellyanne, would you like to expound on that, please?
I mean, my expertise is designing curriculum for elementary and middle school students. So, and thinking about and building upon what Corey and Brooke had said earlier about, the soft skills like collaboration and communication is super important, but also just, even in the curriculum that I designed for elementary and middle school students, really thinking about how you can go from design to make. And a lot of the make and the build has to do with, being able to do quantity takeoff. So thinking about, if I were actually to build this, how much material would I need? Being able to identify the criteria and constraints of a design problem as well seems, very important. And also just kind of building upon what Corey and Brooke was saying is these are big problems that we're trying to solve. and being able to integrate a diversity of viewpoints as like your input to solving the problem is going to be a really great way to meet the criteria that you've set out that is a successful way to solve your problem. Who would like to talk about math?
Yeah, I can talk about math. So when you think about buildings, for at least as I'm understanding, probably engineering would probably be the most applicable portion of math. Again, the engineers have to think everything about how tall the building's going to be, the relationship to the buildings around it. If you're going to be looking at solar energy, what is the angle of the sun during the different times of year? Where is the best placement for solar panels? If you're looking to recover the water from the building, what features do you want to put on top? And do you want to put things on the side to make sure that we're capturing water? Lightning, right? What is the height of the building compared to the other buildings around it, and how tall would a lightning rod have to be in order to safely take the lightning bolt that may come, and then how do you distribute that throughout the building to make sure that everyone and the wildlife around the building are safe. So I think that math would be very, very important. And again, particularly for the engineering, but can also be applied to architecture. And I'm sorry that I failed to mention it, but particularly for electricians, as you're looking at voltage coming in and going out of a building or a space, math is very, very, very important because it's going to mean individuals that are in the building when they're using whatever technology they're using, that they're actually able to get the energy to that part of the building, and running scenarios that says if we're having the building at 50% capacity, what will the energy output look like? Or if we have the building at 100% capacity, are we bringing enough voltage into the building? How many ports do we need to have? Do we need to reroute the streets? I'm sure if you are going through downtown, I know where I live in Mattapan, they're doing it. They're actually reconfiguring the underground electronic panels or electric box panels and the power stations, because we have more technology, because we are building more, and there's going to be some light manufacturing in this area. And they want to make sure that if they're running machines that previously weren't in the area, that there will be less power outages. And they try to basically model what would make a neighborhood or the city short out. And again, that's all using mathematics and formulas. So again, it's kind of an interdisciplinary piece, so it would be mathematics, but then also looking at the science of energy in that sense.
And hearing you say that, Corey, really makes me think, and I'm also a fellow dragon as well, which is why I but for me as a student who always thrived in English and kind of like the arts and humanities and struggled in math, for me, I actually liked the problem solving aspects of math. So if you're someone who's like attracted to math, but maybe sometimes struggle sometimes with math, I really think that the context that construction provides, so like how you can actually like use math and apply math in order to help people make a better world, is really motivating for me, and I feel like would be motivating for other students who maybe sometimes struggle with some of the formulas that Corey still remembers.
I'd also like to call out the point that when you're majoring in mathematics, you're exercising a muscle. You're exercising that problem-solving muscle that's so important to the construction industry. So if you're even not directly applying mathematics, building that skill is incredibly important as a general contractor, but in any construction industry related sector. So I think it's a great major. All we do all day is troubleshoot, and we talked a lot about technology. Just having that ability to troubleshoot will help you to learn any software you need to learn. So that's a positive byproduct.
Awesome. And Kellyanne, we had one more question.
Sure.
So how does the construction industry manage waste? So there's different kind of waste, and to make it short, we have underground waste. So when we're building the building that we are, we're going to go 4 floors down. We have a couple of different pieces. We have some clean fill, which again can be sent to a recycling place. And then we also have some fill that we call dirty, which has to be sent to a treatment center, where before it is put in the ground or wherever it is going to be placed, it actually has to be treated to make sure that it is not going to be radioactive. Steel, concrete, extra, aluminum, things like that. What companies try to do to the best of their ability is store it in large mass, and when they're ready to have truckloads of it go, they'll have a crane or whatever tool they're using actually load it into the truck and then cart it off to the site. So instead of bringing 100 pounds of aluminum today, 100 pounds of aluminum tomorrow, they'll store the aluminum in one space, and when they have an entire truckload, they'll contact the transfer station or the place where the aluminum will be brought, and they'll say, okay, we're going to bring 2 tons of aluminum to you today. And so what that does is that actually allows the company to recuperate some of their costs. So in short, there are pieces where for the dirty fill where you have to pay for it to be taken, but there are also materials that, again, you can recoup some of your costs. And so that is, in short, how waste is managed in the construction industry.
Well, I have learned so much from you all. I just want to thank again our friends at Suffolk Construction for joining us for the future of construction. I'm actually going to share my screen next. So if you guys need to drop off, I understand we went over time, but I just wanted to make sure that I extended my thanks to you all for joining us today.
Thank you very much for having us, Kellyanne.
Thank you.
Thanks. All right, so I'm going to share my screen so that you can see the cool down activity for today. So there's a few, and this is just meant, it's like not homework. It's, you know, if you were inspired by what you saw today and want to extend your learning further, especially knowing that towards the end of the week, we are going to be participating in those design challenges that will eventually be made public by the Design Museum in Boston featuring your work. These are just some activities that can keep you going. So one idea that we thought of is what are some materials around your home or in Tinkercad that you could use to build a model of the structure space from your community. So similar to how I use Tinkercad to model the gas tanks or the gas tank, sorry, in Boston. So that's one activity that you could do. You could also start thinking about how you could take what you learned today about sustainable design to reimagine your neighborhood. And before we go, I also wanted to share with you just some resources. So one is that Make Justice resource that I shared with you before. So that gets into more particulars around thinking about you know, issues of justice in different communities and also issues of environmental justice. And there's some cool videos as well, including our video from James Devlin, who's now retired from the Patriots, but still part of the Patriots family. So that if you look at the bottom, that shortened URL will take you to that resource. So there's a dot before the SK and then /make justice. So I'll give you a second to write that down or take note of it, take a picture of it if you want. The other resource I wanted to share with you is I had given you a quick demo of Formit, which is our conceptual design software. So the advantage of using Formit, not only is it really cool and fun to use and maybe a little bit easier to use than Revit, which is another architectural modeling program that you have free access to. So most of Autodesk software is free for students and teachers. I want to remind you of that because when you go to Google, like if you want to download software, like you don't need to download Tinkercad. Formit, also the advantage of using that is there is a browser-based version that you don't need to download. But if you do want to download Formit on your machine or Revit even on your machine, make sure that you go to the educator. So if you even just do Autodesk Education, if you Google it, that will take you to the right place so that you're getting that free education license. So Formit, again, is our conceptual design software. You can see the cool features of how you can take that geographic information and actually take your object or the design that you're modeling and make sure that it is situated within a real environment. I do want to also say that they use Bing Maps, not Google Maps, as best practices for using Formit. And the reason for that is that Bing has higher resolution imagery for the geographic imagery, and also it gives you like a north view so that it's like a bird's eye view of the top of building so that you can actually grab some of that information from the map and extrude it into the actual building. So what you see at the bottom here is a shortened link to a tutorial for how to build the Farnsworth house in Format. So I'll give you a moment to take that down as well. That's a shortened URL. But also, even if you just Google Farnsworth, that word, and Format, it will be one of the first things that comes up. And that gives you a step-by-step process for how you would build it. Finally, I just want to remind you that tomorrow we'll be meeting again. And again, it probably might be a little bit more closer to an hour tomorrow, but I'm sure Khalif from Mass Robotics will also be glad to hang around and answer your questions. But tomorrow, same time, same place, you can use the same URL for Zoom that you got in your email to join. Again, tomorrow we'll be talking about the future of construction, and we're going to be specifically focusing on the integration or the intersection of robotics and construction. And again, that will be Khalif Mitchell from Mass Robotics who's going to be presenting tomorrow. I'm excited. It was really fun the last time he presented. And I think that's all I have for today. So I just want to say thank you to everyone who participated today, who shared questions in the question and answer. And I look forward to joining with you tomorrow and to learn more from you and to see what you create as a result of this series. So thanks again and have a great rest of your day.